In this video, we're going to construct a trial and error solution for the production model. If you don't have these headings on your worksheet, you should pause the video and set up your worksheet to resemble the one you see on the screen. In the production model, we use the general notation for the inputs where C equals profit per unit, A equals production time in hours per unit, and B equals production capacity in hours. We're solving for X, which is the production quantity. We're provided with some input data. The input data includes per unit profit, and that is $10 per unit. So we'll enter that as C, profit per unit, 10. We're provided with 5 hours per unit of production time. Each unit requires 5 hours to produce. And we're provided with 40 hours as a constraint for the amount of production time available. So I'll put that here. There are many ways to set up this model. This is just the one I've chosen. In the textbook example, the decision alternatives, the production quantity X, is provided by 2s, so 0, 2, 4, 6, 8, 10. I'm going to provide them by 1s. Excel makes this very easy. We're not calculating this by hand. So I enter 0, 1, 2 to get Excel started with the progression. Then I select 0, 1, 2 by clicking with my mouse and dragging down. Move my cursor to the autofill node, left click and hold the mouse button, drag that down, and you can see it counts down to 12, which is how far I want to go. So I get my numbers 1 through 12. I'm going to select the entire range of outputs here and do a little formatting. I just want to center these so they're a little easier to read. Now I want to put in my projected profit. I know that the profit I make for each unit that I sell, I can't sell a unit unless I produce it, is $10. So I'm going to use a relative and absolute cell reference combination to select the production quantity relative times the projected profit per unit of production. I'll make that absolute. That way I could copy this formula down and only enter it one time for this column. However, if I did this a little different, I could copy this formula down and to the right. So let's do it that way, just to properly illustrate the use of relative and absolute cell references. I'm going to think about how I'm going to copy this formula. First of all, I want to take production quantities, and whether I copy it down or whether I copy it to the right, I have different criteria. First of all, when I copy it down, I want it to change. I want it to look at the appropriate production quantity. So I want the row to remain relative. But as I copy it across, I want the column to stay the same because this is the column where my production quantities are. So I'm going to press the F4 key 1, 2, 3 times, and that's going to lock the column. Then I'm going to multiply that times my profit per item. And as I copy that down, I want it to stay locked on that row because that's the row where my input data is. But as I copy it across, I want it to move to the input data for the appropriate column. So I want it to move from projected profit of $10 to production hours of 5. So I'm going to set this to lock the row by pressing the F4 key twice. When I do that, now I can copy this down Then I can copy it across using my autofill node, and I do some checks here, place my cursor on a value, press F2, and see that yes, it's looking to the appropriate values, using them in the calculation. The same there. Now, I only have 40 hours of production available, so I want to check to see which of these solutions are feasible. Then from the feasible solution set, I'll determine which of the solutions is optimal, so the best solution. I'll use a simple if statement. I'm going to enter if the production hours value. I'll leave that relative because I want to look at this production hour value is less than or equal to the maximum available production hours, and I'm going to lock that by pressing F4 once, make that an absolute cell reference. Then I want to type yes, that it is feasible, comma, otherwise, in quotes, enter no, and then a closing parenthesis. And then I'll copy this down using the autofill node. And we can see that the last yes is production quantity 8. So using the trial and error method, the optimal feasible solution in this model is a production quantity X equals 8.